This video will be about scalar multiplication of matrices. So when you multiply by a scalar is basically a number outside the matrix. So we have 3 outside, and inside we'd have negative 2, 0, 5, 1 for this particular matrix. Every matrix is different. So this number outside, it's like a 3 outside a set of parentheses. You multiply it in times everything on the inside. You do 3 times x, 3 times negative 1, you'd have 3x minus 3. Well, same thing here, but you're going to multiply the 3 times everything inside. You'd have 3 times the negative 2, 3 times the 0, 3 times the 5, and 3 times the 1. Most of the time we don't write out what we're multiplying. We just go straight to the answer, because most of the time we just say, well, 3 times negative 2, well, I know that's negative 6. 3 times 0, I know that's 0. 3 times 5, I know that's 15. 3 times 1, I know that's 3. So you can just go straight from the first matrix all the way down to the answer. But this is just to show you the thought process we use to get from one to the other. You can also do scalar multiplication with a fraction in front, but you're still multiplying the 2/3 by everything on the inside of the matrix. Now our matrix is a different size this time. That doesn't matter. We still multiply by everything inside. So 2/3 times the 9. If you're not sure how to multiply the fraction out, you can plug it into your calculator as 2 divided by 3 times 9. The fraction bar is just a division symbol. So 2 divided by 3 times 9, that will give you 6. And then we do it to the next one. 2 divided by 3 times negative 6, that's going to give you negative 4. And you just keep going in that same manner. 2 divided by 3 times 15, that gives you 10. 2 divided by 3 times 0 is still 0. Anything multiplied by 0 is 0. 2 divided by 3 times 3 is 2. And 2 divided by 3 times negative 12 is negative 8. So this 2/3 fraction, you're just going to plug it into a calculator. And that decimal that it looks like there was just because I was pointing. That is really 12, not 1.2. So 2/3 times negative 12, did it again. It's just negative 8. So that's how we multiply the scalar in. What they may do to make it just a little more difficult is have you do some addition and subtraction with your scalar multiplication. So let's say we have A, matrix A is 2, 3, negative 7, 1, 4, 5. Matrix B is 3, 0, 6, negative 1, 8, 2. And then the way they would ask this question is they would give an entire expression. They'd say 3A minus 2B. This means multiply 3 times matrix A, multiply negative 2 times matrix B, and then combine them together. So we have 3, and then we write in matrix A minus 2, and then we write in matrix B. Now we actually do the multiplication. Multiply 3 in to everything. This would give us 6, 9, negative 21, 3, 12, and 15. We're going to multiply negative 2 times everything, and since we're taking the negative sign with us, this will change to plus. So this will change to plus, and you have negative 2 times 3 is negative 6. Negative 2 times 0 is 0. Negative 2 times 6 is negative 12. Negative 2 times negative 1 is positive 2. Negative 2 times 8 is negative 16. And negative 2 times 2 is negative 4. So once you've done your scalar multiplication, Now you can just do your matrix addition, which you learned in a previous lesson. So we go corresponding elements. 6 plus negative 6 is 0. 9 plus 0 is 9. Negative 21 plus negative 12 is negative 33. 3 plus 2 is 5. 12 plus negative 16 is negative 4. And 15 plus negative 4 is 11. So that is your final answer for that matrix expression, simplifying that matrix expression. They can also apply this to solving a matrix equation. Again, in previous sections, you've learned how to solve a basic matrix equation. This is going to take it one step further. So you have to do a couple of things before this can be solved. So here is our matrix equation. So first, if you do have a scalar in front of the matrix, you do need to multiply it in. So everything else will stay the same so far, but we're going to multiply 3 times everything inside here. 3 times 2 is 6. 3 times negative 8 is negative 24. 3 times negative 4 is negative 12. And 3 times 2 is 6 again. Now we can start doing our opposites. So we want to get rid of this whole matrix and move it to the other side. It is adding right now, so the opposite would be to subtract. So we're going to subtract this whole matrix from both sides. On the one side where it was the opposite, it cancels. So we just bring negative 2x down. On this side, we've got to combine. I forgot to put the minus sign in, but we are subtracting on both sides. So 4 minus 6 is negative 2. Negative 6 minus a negative 24. When you have a minus minus, that changes to plus. So really this is negative 6 plus 24, which is positive 18. 2 minus negative 12. We've got the minus minus again going on, so 2 plus 12 is 14. And negative 8 minus 6 is negative 14. So once you've done your subtraction, or possibly, it could be addition. If it started out as minus here, the opposite instead would be plus. So you have to watch and do the actual opposite. Now we have negative 2 times x left here. There's really a multiplication symbol that they're not going to write in. You just have to know, oh, this is really negative 2 times the letter x. So our opposite will be to divide by negative 2. So when we come over here to our matrix, just like multiplication goes to everything, if you're doing scalar division, the dividing will go to everything. We're going to divide all of them by the negative 2. So it cancels on the left. That's why we did the opposite. Negative 2 divided by negative 2 is 1. 18 divided by negative 2 is negative 9. 14 divided by negative 2 is negative 7. And negative 14 divided by negative 2 is positive 7. So that concludes our discussion on scalar multiplication for matrices.